Hello there. Nice to meet you.
Hello, I am Muizuddin from Company Fence. How can we help you with your problem?
I had a problem. My garden is insecure. There are many animals that always damage my garden. So I need to settle this problem as soon as possible.
Ah, that's easy. Actually, I can suggest you to put some fence on your garden so then no animal can come through to destroy your garden.
Wow, sounds great.
But first of all, I need your information about your garden.
Around 500 feet.
Ah, so for your problem, we're going to use differentiate application. Oh, sorry. Application differentiate. So I can find your maximum area to put the fence without a problem. Of course, we need a maximum, right? We don't need minimum because we want your garden big enough to grow. Okay, Assalamualaikum warahmatullahi wabarakatuh. And today I'm going to show you how to do application differentiate to solve the problem to put the fence. As you can see, the problem is they want to put the fence on the garden, but they need our help. So we're going to help with application differentiate using maximum area possible. And as you can see,
their garden is 500 feet. We're going to find their maximum area possible. So first of all, we're going to use perimeter first because they give their perimeter, which is 500, their perimeter, and we're going to use x, y. But as you can know, perimeter is x plus y plus y. So we're going to use 2x plus 2y equal to 500. Okay, so we're going to solve this. We're going to solve 2 by divide it 2. So it's going to be x plus y equal to 250. We're going to solve it more. Y equal to 250 minus x. Next step, we're going to use area. And as you can see, area is equal to x multiplied by y. So we can differentiate this because these have two variables. So we're going to need one variable. We're going to put this inside y. As you can know, this method is called subtraction. So it's going to be x multiplied by 250 minus x, and it's going to be 250 x minus x power of 2. But next, as you can know, relative maximum point is function x equal to 0. So we're going to differentiate a, which is area, and x. So it's going to be dA per dx. So when you differentiate area, it's going to be 250 minus 2x. Because why? Because 2 go to the front, it's going to be 2x, and power 2 minus 1, because that is the formula. Right. Equal to 0 because relative max point is equal to 0. So we're going to solve this. 250 equal to 2x, and we're going to solve it. So it's going to be x equal to 125. So this is going to be critical point. next step, we're going to make some table. So we're going to make some table. 1, 2, 3, 4. So it's going to be like this, and this is X and this is A. So for minimum it's always 0, and next is critical point is 1 to 5, and maximum is 250. That is their maximum. So we're going to solve this. We're going to find A using, so we're going to solve this to put inside this. So it's going to be 250x minus x power of 2 is going to be 0 at here. And when you use 1 to 5, 250 multiplied by 1 to 5 minus 1 to 5 power of 2 is going to be maybe it's gonna to fit, so I'm going to put it outside. 50,625, and next is maximum point. It's going to be 250 multiplied by 250 minus 250 power of 2, so it's going to be 0. And as you can know, x equal to 1 to 5, y equal to 250 minus 1 to 5, so it's going to be 1 to 5. So you want to know if the area is true or not, it's going to be x multiplied by y. So it's going to be 1 to 5, so it's going to be x multiplied by y. So you're going to be 1 to 5 multiplied by 1 to 5, and you can get 15625. So the maximum error is 150,625 feet.
Okay, I want to talk about the conclusion. The application of differentiate. The application of differentiate is used to compute the rate of change. We can accurately count the difference in change happen. Rate of change are very connected with time, so the application will give us the specified time in our life. Student can calculate it by using the formula. As well as being able to differentiate, you should find that you are increasingly able to communicate mathematical ideas and apply your knowledge understanding the mathematics in everyday life. You should now be able to first understand the idea of differentiate from first principles. Second, differentiate power function. Third, find stationary points of some function. Fourth, determine the nature of some stationary point using either the first or second derivative test. 5. Understand and work with derivative as rate of change in mathematical model. The application of differentiate helps us to know the accurate distance of the aeroplane and the control tower. We also can count the range of change in our own water tank at our house. Everybody say the mathematics is not important in our life. They say the mathematics is very difficult and so depressed when we learn. But they did not know the aeroplane cannot fly without the application of differentiate. Okay, thank you.
Thank you.